Okay, today is daily problem 909, snakes and ladders. That has been solved by me before, like 4 years ago. Let me read it and I'll start solving. Okay, so this looks like BFS problem. The only thing I need to figure out here in this problem is how to proper account for the for following snakes or ladders. So if I follow snake once, I cannot follow it again. So as I say, like this case, let's say it's this board, so it has -1, 4, and then -1, 3, and they say that something, for example, suppose that the board is this one, and on the first move, your destination square is 2. So what's the destination square here? On 2, okay. So I go like here. And then from here I can jump to the next row, to 3. But then from when I jump from 3 to 4, I cannot jump again from 4 to -1. It's not allowed. So I wonder if I should keep the int to have this array in a queue, and then increment the number of jumps, steps or jumps. So say I have like jumps, and then I have 0 or 1 if it means that I follow the ladder. And it means that if I take it and I have like now also on a ladder, oh, actually I can just follow the ladder by default. You must move, okay. So if a next jump is on a ladder, I'll on a ladder cell, I'm instantly gonna jump to the next one. Something like this. And I can also like maintain the current cell index here, cell index. So I don't need this 0, 1, so just cell index. And then say we have I and jumps, where I is a cell index. And then I can derive the, let's say I call it K, and from K I need to derive I and J from the board, and I know that there is given N. So how to derive I. So I is easy. I need to k minus 1, and then I need to divide it by n, and then n minus 1 minus this one. And this is gonna be the index I. So let's say we have 1 here, k is equal 1, 1 minus 1, 0, and it's gonna be n minus 1 row. So, and then the column is a little bit, so I should be n minus 1 minus k minus 1 divided by n. So j is a little bit a tricky one, because like if it's like 0 row from the, if it's like even row from the end, it should go from left to right. Otherwise it should go from left to right. Otherwise it should go from right to left, like this. So first of all, I need to figure out, is it what the row it is. Is it like even or odd? So I need to do k minus 1 over divided by n. It's going to be the index of the row starting from the end. So it's going to be 0, 1. And then I need to do mod 2. And if it's mod 2 equals 0, so it's going to be even. If mod 2 equals 1, it's going to be odd row. So in case this is even, I need to do the following. I need to do k minus 1 mod n. And in case it's odd, I need to do n minus 1 minus k minus 1 mod n. And that's gonna be my function for the derivation. So let me program this one. So I have this board, and I'm gonna have q int equals new q int like this. And then I'm gonna have cells over new int one 0. So 1 is k, index k, and 0 is number of jumps. And then I'm gonna have boolean visited equals new. So I'm gonna have also int n equals board length, and then visited is gonna be a new boolean n, and then visited 0 gonna be equal. So I'll convert it to 0. So I'll start from index 0. Visited 0 gonna be true. And then while not cells is empty, I'm gonna go into cell, gonna be self poll, and then I'm gonna do something like int I gonna be cell 0 divided by n minus 1 minus cell 0 divided by n minus 1 minus, so k minus 1, so I skipped this one, so I already stored the k as k minus 1. And then in j gonna be, so I need also to do this for I'll create this function private int chord int k and then int n, and then I'm gonna go int I equals k n minus 1 minus k over n, and then int j gonna be k over n mod 2 equals 0. Then I'm gonna have one set of j's, otherwise I'm gonna have other. So this is gonna be just k mod n, and this gonna be n minus 1 minus k mod n. And then I'm gonna return this coordinates, return new int ij. So here I wanna go next for int I equals 0, I less than n, less than I equals 1, I less than or equals 6, I plus plus, and then int next k gonna be cell cell 0 plus I, and then int coordinates gonna be coordinates next k and then n, and then I need to check if board, first of all I need to check if this, if next, if visited next k, if it was visited I continue, if not I'm gonna get next k, so visited next k gonna be true, and then if board chord 0 chord 1 not equal -1, so int board value gonna be this one, and then if it's not equal -1, it means that I need to go and say next k gonna be board val -1, and then I'm gonna need to do visited next k gonna be true, and then q.offer new int next k, and then I need to increment the number of jumps, cell 1 plus 1, so that's gonna be it. And then if I find, so if I exit without returning, I'll just return -1. It's not possible to reach it, the final cell. But if next k gonna be n by n -1, then I'm gonna return cell, oh no, so like if cell 1 cell 0 gonna be equal n by n -1, then I'm gonna return cell 1 number of jumps. So that's it. A few errors. Yeah, so I cannot reuse it. Yeah, so like basically the idea was that if I jump one time, I cannot mark the node, the destination node, the final destination node as visited, as otherwise I might be discarding too much. Like, so like in this case, I would consider like, okay, let's say we have this example. Say we have this example, like 3 cells here. And then it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say here is like this path. And here is this path. So when I consider like I equals 1, so I stay here initially. And I consider I equals 1, 2, 3, 4, 5, and 6. So like dice can be from 1 to 6. And then let's assume I check jump on like 2, I mark this as visited, true, visited, and then I mark this also visited as true. And then this will basically, when I gonna consider k equal 1 plus 5, I'm gonna consider this jump, but I won't be able to process it because I already marked this as visited. But that's not true. It should not be marked as visited because in this case the optimal number of jumps is actually 1. So you jump from 1 to 6, and then from 6 to 9 you use ladder. But if I mark it like both cells as true and true, then it means that I'll need at least like 2 jumps to reach the final destination. So like a jump maybe from, I can either go like here, from 1 I can go here, I can go here, I can go here. No, actually I cannot go. I cannot go here actually. cannot go here. So like I can go here, I can go here, 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 and then I can go actually here. And the second jump gonna be here and here. If I mark this already visited. But if I don't mark it as visited, that's the right approach, not to mark visited the final destination when you do the jump. So I can like instantly go like have a dice of 5. So I'll go here and then I use a ladder in one turn go to 9. I'm gonna be just one jump. So dice go 5, jumps in this case gonna be 1. Yeah, so that was a good counterexample. That's it.